Today we're going to look at the derivative of an inverse function. So let's review inverse functions first. Okay, so a function g is the inverse of the function f if, when we take the composition f of g of x and it equals x for each x in the domain of g, and g of f of x equals x for each x in the domain of f. And so therefore, when we do the inverse, the domain of f is the range of g, and the range of f is the domain of g. All right, so here we want to show that these are inverses. So to show that these are inverses, when we do the composition, like f of g of x, like this, we're putting g inside, so it's 2. And then we're doing this. We're doing the cube root of x plus 1 over 2, and then it gets cubed minus 1. Okay, it's supposed to equal x. So here when I cube this, I get 2, then x plus 1 over 2 minus 1. Well, the 2's cancel, and I'm left with x plus 1 minus 1. All right, so far so good. And then when I do it the other way, g of f of x, all right, so that means I'm putting f inside of g, so it's the cube root. Okay, for that x, I'm going to say 2x cubed minus 1, and then plus 1 over 2. So here we go, the cube root of, it's going to, the 1's cancel, 2x cubed over 2, and then those cancel. All right, and the cube root of x cubed is x. So if the composition both ways, both equal x, then yes, they are inverses. And you should have done this in pre-cal at some point. Okay, so let's actually find the inverse. All right, if we recall finding the inverse, what would we do? We would switch our x and y's and say this is y right here. So then when we switch them, that's x equals 7y minus 5. And then I would solve for y. So x plus 5, and then I would divide by 7 equals y. Or remember our notation. It'd be f, it looks like f to the negative 1, but that stands for inverse, equals x plus 5 over 7. So if I want to find the inverse at negative 1, I would just plug in negative 1. And I get 4/7. Now, I can also think of this in a different way. If x equals negative 1 in the inverse, then y equals negative 1 in the actual function. So what I could have done was I take this function right here and I plug in negative 1. And then I solve. So here that would give me 4 equals 7x, and I divide by 7. And I still get 4/7 equals x. So that's another way to think of it. All right, so let's apply this to the derivative of inverse functions. The derivative of inverse functions, let f be a function that is differentiable on the interval I. If f has an inverse function g, then g is differentiable at any x, for which the composition of f prime of g of x doesn't equal 0, and g prime of x equals 1 over f prime of g of x, where f prime of g of x doesn't equal 0 either, because that would be in the denominator. All right, so here we go. When we talk about the inverse property, okay, we know that f of, and say we have the inverse, we know it equals x right there. All right, now think about this. If we take the derivative of this, all right, if we take the derivative of each one of these, also this side is easy, that equals 1. All right, this side, think of your way from the outside in. It's going to be f prime of s to the negative 1 of x. And then you do the derivative of the inside. So it's going to be basically the derivative of that. So therefore, think of this as this part right here is the derivative of the inverse. So if I solve for that, the derivative of the inverse equals 1 divided by f prime of f to the negative 1 of x. Put this into your memory bank. All right, put that into your memory bank because we're going to keep coming back to that. All right, the more you use it, the more you'll have it memorized. So let's go look at this problem right here. I want to find the derivative of the inverse of 3. Okay, so basically I'm finding, okay, well let's recall this. If you need to rewrite it over and over again. All right, well here what I need is the inverse. All right. So I need to know what the value of to plug in for this part right here. Okay. Well, think about it. If the x value is 3 in the inverse, okay, then it's going to be 3 for the y value in the original function. So what I want to do is I want to solve for x here. Well, I'm going to take my calculator and I'm going to find where this is equal because this isn't easily solved. Sometimes it's going to be something that's easily solved for. So 1/4 x to the third plus x minus 1. All right, and then I say equals 3. So zoom 6. Not sure what my window was beforehand. And I want to find where these cross. And it's only going to cross in one spot, and there's that value. So second trace, 5 for intersect, 1, 2, 3. Okay, and I get x equals 2. All right, so here we go. So I know that this value right here is 2. So now all I need is the derivative of f. Well, here, what's the derivative of f? Okay, well that's going to be 3/4 x to the second plus 1. Well, now I need to know what that value is at 2. All right, so 3/4, 2 squared plus 1. Well, these are going to cancel, and I'm going to be left with 4. So this equals 1/4. All right, so let's do this again. I'm trying to find the derivative of the inverse. Okay, so recall this. Derivative, and then the x value is 29. So it's going to be g prime of inverse of g at 29. Okay, think. The x at the inverse is this, so for the real function, I can plug it in for y. Now this one is kind of easily solved for. We can solve by subtracting that, so that's going to be 25 equals x squared, and when I take the square root, I get plus or minus 5, okay? Don't worry, it can be plus or minus. Okay, so what I'm going to do is 1 over g prime plus or minus 5. All right, so now I'm going to find the derivative of this because that's what I need. I need the derivative. So it's 2x. All right, so what I'm going to do is plug plus or minus 5 into here. And you're not adding that, it's times. So that's plus or minus 10. So this equals 1 over plus or minus 10. So it's either 1/10 or negative 1/10. All right, moving right along. Let's find the inverse. And again, the more you write this down, the better off you're going to be. That's how you memorize. Just practice, practice, practice. All right. Here the x value is 8, so therefore if I set it as the y value, you take a second and find where these intersect. I already know they intersect at 1. All right, just remember, plug one side into y1 and one side into y2, find their intersection. All right, so this is 1 over f prime of 1. Well, I've got to find f prime. Okay, so that's going to be 6x squared plus 5. And then when I say f prime at 1, when I plug 1 in there, 6 plus 5 is 11. So this makes 1 over 11. All right, so that makes 1 over 11. All right, let's evaluate this one. Try it on your own, okay? That's how you're going to get a lot better at this. So right now I'm trying to find this intersection to find that x value. Second trace, 5 for intersect. All right, and I find that it's at 1. All right, so therefore it's 1 over f prime of 1. Okay, so if I find f prime of x, all right, that's going to be 9x squared minus 1. All right, so f prime at 1 is going to be 9 minus 1, which is 8. So this is 1/8. Give yourself a pat on the back if you got that correct. And we're essentially just doing the same thing. We're going to come across different functions, so I want to make sure that we hit all the functions. I'm changing this so this is x to the -3. I always think that's a lot easier to find the derivative of. So your final answer should be, and I don't know, I might have done something wrong here. So I got x equals 2. No, I think I got it. Oh no, I don't. I got, here's one thing I forgot. I see what I did. I plugged this one right back in. I was supposed to write this, that equals 2. So, and I've used f instead of h. Okay, so here, this is going to be 2 to the 4th, all right, which is 16. Well, what it is, let's see, -24 over 16, and 8 comes out, so that's -3/2. All right, well, think, this is 1 over 3/2, which equals 2/3, and it's actually negative, so -2/3. So be careful on that. I'm sorry for that mistake. All right, we all make them. All right, so here we go. All right. So here the x value is 1. All right. That means I've got to set that equal. All right, and I'm going to solve it. Solve it on your calculator, and when you solve it, it's x equals 1, not 0. X equals 1. So here what I do is, and this is where I messed up last time, if you replace that, it'll make more sense, and you actually see that you're supposed to take the derivative. Okay, and now I'm supposed to plug in 1 into that derivative. And I get 2 minus 3, which is negative 1. So this is 1 over negative 1, which is negative 1. All right, and I've got 2 more. And you'll notice these two are a little bit different because I got e to the x and ln of x. All right, so make sure you see these. So this is going to be 1 over, all right, h prime of h to the negative 1 of e. All right, so here, this is x for the inverse, so that must be y. All right, whoops, e equals e to the x. Okay, we'll think about it. You can take the natural log of each side, but think, if I have the bases that are the same, this exponent's 1, so x just equals 1. All right, so this makes 1 over h prime of 1. Okay, h prime is just e to the x. All right, and when I find h prime of 1, well, that's e to the first, which is just e. So it's 1 over e. All right, and then lastly, this one right here. All right, so it's 1 over f prime of the inverse of f at 0. Okay, so remember, this is the x for the inverse, so therefore, for the original function, it can be the y. Well, when does ln of x equal 0? When x equals 1. Or you can take the e of each side, and you'll realize e to the 0 is 1. All right, so here I'm going to replace it. I've got to find a derivative. Okay, the derivative of that is 1 over x. All right, so here when I plug in 1, 1 over 1 equals 1. So this is 1 over 1, which equals 1. All right, so make sure that you have this part, our inverse property of the derivative, memorized. All right, so that we can use it.